Okay, so I'm going to take up the quiz from today. According to the pH scale, which of the following substances is a base? And according to the pH scale, which goes from 0 to 14, 7 being neutral, those to the left are acids and those to the right are bases. So if you put your bases on here, or your acids and bases, there would be ammonia, there would be water, there would be lemon juice, and aqueous hydrogen fluoride. Okay, so ammonia is over here on the base side, so that's why B is the correct answer there. Which product has a bitter taste, is slippery when mixed with water, and can damage your skin with prolonged exposure? What you needed to do is to be able to identify that as base, because those are the characteristics of a base. They're bitter, they're slippery, just like soap, and can damage your skin. We talked about grouting tile and things that damage your skin. So you need to find the base. And the base is sodium hydroxide, because hydroxide is what we talked about identifying a base. If you see a hydroxide, you're going to see a base. If you see a hydronium ion, you're going to be an acid. Tomato juice is an acid, vinegar is an acid, and lactic acid is an acid. So A is the correct answer. Which of the following is a homogeneous mixture? Don't forget, a homogeneous mixture is ones where if you take two samples of it, it's going to be exactly the same. So we looked in the textbook, I think it was page 203, we looked at different types of homogeneous mixtures. Granite has specks in it, so it won't be homogeneous. Brass, if I take two pieces of brass, they're both going to look the same. Pizza, if I take different slices, they're going to have different stuff on them, and fruit salad is not going to have the same stuff if I take two samples. Remember back when we talked about samples. Okay, in the graph below, the solubility of two compounds are shown. Which of the following best describes the graph? Okay, I want you guys to remember, we have to look for what best describes it. As temperature increases, the solubility of potassium chloro, it's not coming to me. The solubility of this decreases. Well, let's take a look. It goes up, so that's not the correct answer. As temperature increases, the solubility of cesium sulfate decreases. As temperature increases, yep, that's true. Decreasing the temperature will increase the solubility of cesium sulfate. Well, decreasing the temperature will increase, yep, that's correct. And no change occurs in the solubility of KClO3. Well, there is obviously a change. If there was no change, it would be straight across. Okay, so that's incorrect. So now we want to look at the one that's the best. As temperature increases, the solubility of cesium sulfate decreases. Okay, and what I want you to understand is that you always read from left to right. Okay, so we're looking at the graph from the left to the right. So the one that works out the best is as temperature increases, the solubility decreases. Okay, for the next two questions, considering the following reaction. Hydrochloric acid and water gives 2 chlorines and 2 hydronium ions. Okay, so how many molecules of hydrochloric acid would be needed to balance this equation? Okay, so what we need to do is look at the hydrogens on this side. We have 1, 2, 3, 4, 5 hydrogens, and over here we have 6. If we look over here, we have 1 chlorine. Over here we have 2 chlorines. So this is the one that we're going to have to alter. So if I just multiply this by 2, I'll get 2 hydrogens, 6 hydrogens, 6 hydrogens. So that's good. I have 2 chlorines, 2 chlorines, 2 oxygens, and 2 oxygens. So I'm good. So it would be B2. The product of this reaction is, these are the products. Take a look. That's that hydronium ion. So hydronium tells you that it's an acid. Okay. When 32.9 grams of hydrochloric acid is mixed with sodium hydroxide, it produces salt and water. If there's 46.3 grams of product, what is the mass of the sodium hydroxide? The reaction equation here And so what we need to do is find out how much of this we have. We've got 32.9 of this, and it says the product mass of the product is 46.3. So this is the product, and that's 46.3. So in order to find this, it's 32.9 plus x equals 46.3. X equals 46.3. Take away 32.9. And if you look, you can probably just do the mental math, and you see that it would be C, 13.4. Okay, that's the law of conservation of mass. Number 8, which of the following would not improve solubility? Okay, so let's take a look and see. Let's first of all look at the things that improve solubility. Heating the solvent, does that improve solubility? Yes. Crushing the solute? Yes. And this is where you need to use your mental model, TUV. The solvent is the one on the bottom. The solute goes into the solvent, and a solution contains a solute and a solvent. Stirring the solution. Well, if I stir up my solution, it's going to help to dissolve it, because it'll help to mix in the components. And crushing the solvent, can you crush a solvent? You can't crush a solvent. So crushing the solvent does not improve solubility, so that is the correct answer. Why does heating a solvent improve the solubility of some substances? Okay, so heating the solvent, and don't forget, when we heat things, what we do is we speed up the particles, we speed up the molecules, so they're moving around a lot faster, and the chances of them bumping into each other increase. So it decreases the speed of the particles. No, that's incorrect, because heating increases the speed. It increases the amount of solvent. No, we still have the same amount of solvent. Don't forget, it doesn't change how much you have. It increases the chances of particles contacting each other. That's a good answer. And it makes the solute warmer, so it slows down. That's not correct either. Okay, so C, it increases the chance of the particles coming in contact with each other. Number 10, Miranda and Brett are mixing substances to observe the changes that take place in a chemical reaction. Which of the following would indicate that a chemical change took place? We need to remember our indicators of chemical change. If you see a gas, if you see a precipitate, if you see a color change, and the new one, if we see a temperature change. Okay, so let's take a look. A clear lemon-scented liquid continues to smell like lemons when mixed. Well, none of these things are evident, so that would not be one. A piece of shiny metal floats in a container of liquid. None of these pieces of evidence are there. A white solid disappears when mixed with water. A gas, no. A precipitate, no. A color change and temperature change. None of those things are indicated. A solid mass forms when a yellow liquid is mixed with a clear liquid. Okay, a solid forms. And we know that when we add things together and a solid forms, that's a precipitate. So that would be it. D. Which of the following would be considered endothermic? And don't forget, endo means in, heat goes in. Okay, zinc and hydrochloric acid. Well, we know that's exothermic because we did that in the class. Exploding a firecracker. Well, exploding a firecracker actually lets off heat because it would hurt if you touched it. Melting ice. Well, in order to melt ice, we need to add heat. So that's endothermic. And shining sun. The sun shining is actually letting heat out. So that would be not be endothermic. Okay, so melting ice is a perfect example of something that you have to add heat to in order for it to happen, because we have to heat the ice in order for it to melt. So that would be endothermic. In order for reactants to combine to produce new compounds, what must take place? Okay, so don't forget when these guys go into solution or go to a party, you've got to break their bonds. They've got to stop holding hands so that they can form new bonds with somebody else. Okay? So they must get closer together. Well, they might be closer together, but that's not going to make them form new compounds. The products must be heated. Well, sometimes you don't need to heat them. And the product shouldn't be heated. It should be the reactants. Their bonds must be broken. Yes, in order for them to react with something else, they have to break their bonds. They must slow down. Well, usually they heat up. Occasionally they'll slow down, but that's not what is required for reactants to make new compounds. Okay, the bonus question. Explain why a water molecule is polar and how water easily dissolves table salt or sodium chloride. Okay? Be sure to include diagrams of the molecules and the charges as well as their locations. Okay, so this comes directly from a lesson in class where I talked about an oxygen molecule that has 6 valence electrons. So the octet rule says that this guy's got 2 available spots. And just like I said, it's like 2 seats are available. Okay? Along comes hydrogen, because we're talking about water, which is H2O. And the hydrogen gas will come in contact with the oxygen. And what happens is hydrogen has this single valence electron, and he wants to get rid of it. So what he'll do is he'll put that electron in the empty seat in oxygen's valence shell, and another hydrogen will come along and do the same. Now, since they're giving electrons to oxygen, they're actually becoming slightly positive. Okay? And since oxygen is gaining electrons or negative charges, it becomes slightly negative. So we end up with a polar molecule, and that's what we're looking for. Why is it polar? Well, because the opposite ends are charged oppositely. One end is positive and one end is negative. That's what makes it polar. Now, why does it dissolve table salt so easily? Well, if you look at sodium and chlorine, we get the same thing. Okay, so here's chlorine. Chlorine is in group 7A, so he's got 7 valence electrons, 7. And sodium is in group 1A, so he's got 1. So chlorine's in the same situation as oxygen. Chlorine accepts 1 electron from sodium. So chlorine becomes slightly negative and sodium becomes slightly positive. Okay, so there's sodium. So the positive sodium will go over to the negative end of water, and the positive or the negative chlorine will go to the positive end of water, and that's why it dissolves, because water is able to split apart this combination of sodium and chlorine. Okay, so that's why a water molecule is polar, because it has oppositely charged ends, and it dissolves table salt because opposites are attracted to one another. So the sodium is attracted to the negative end of water, and the chlorine is attracted to the positive end of water.